So this is the last unit the last lesson for our probability unit. We've got more vocab. This unit is very heavy on vocab. So now we've got compound events, which are it's just two or more events. And typically you'll see these events linked by the word and or. So for example, what's the probability that a car in the parking lot is a Chevy and red? So that would be a compound event. Mutually exclusive events cannot occur at the same time. So for example, you cannot roll an even number and roll a 5 at the same time. So the probability for mutually exclusive events is you just add the probability of each event together. For overlapping events that can occur at the same time, so for example, rolling an even or rolling a 2, what we have to do here is subtract the probability that they both occur. So I'm going to run through this one quickly for you. So the probability of rolling an even or a 2, so that's rolling an even will be our A, event A. Rolling a 2 will be our event B. Sorry, this right here should be an equal sign, not a plus sign. So we're going to take the probability of A, the probability of rolling an even, which is 3 out of 6, plus the probability of rolling a 2, which is 1 out of 6. Minus the probability that they both occur. So rolling an even and a 2 would be that 1 out of 6. So we would end up with a 3/6 or a 1/2 probability because we can't double count that event where we roll an even and a 2. All right, so we're going to take a look at mutually exclusive events first. So thinking about a deck of cards, drawing a 2 or a face card. You cannot draw a 2 and a face card on one pull because a 2 is not a face card. So we're just going to add our probabilities together. So in a deck of cards, we have 4 2s. And the face cards are the Jack, Queen, and King because they have faces on them. Common question is an ace a face card? And it is not. So we have 3 face cards in each suit times 4 suits. Gives us 13 face cards for a total of 17 out of 52. For example B, rolling an even or a 5, these cannot happen at the same time, so we're just going to add those probabilities together. So the probability that we rolling an even is 1/2 or 3/6. Let me simplify that, because then we'll have a common denominator that'll be easier to add. So rolling an even, there's 3 evens out of 6. Or rolling a 5, there's 1 5 out of 6 for a total of 4 6 or 2/3. Overlapping events. So these are the ones where we have to think a little bit more carefully as we're calculating the probability. So when we think about drawing a heart or a 5, there is a 5 of hearts. So you can, on one pull, draw a heart and a 5. So when we're calculating this probability, there are 13 hearts out of the 52 cards, plus 4 5s out of the 52 cards, minus the fact that we counted the 5 of hearts twice. We counted it as a heart and a 5, but it only exists once, so we have to subtract that double counting, that 5 of hearts. So we have 13 plus 4 is 17, minus 1 is 16 out of 52. And when we divide them both by 4, we get 4/13. For rolling an even or a 2, we actually already calculated that probability, so we're going to move on. Now what we need to do is decide whether or not the event is mutually exclusive or overlapping, and then we'll calculate the probability. So for A, I want you to think about this. The weather for next week is supposed to be sunny on Monday, Tuesday, and Thursday. What is the probability it is not sunny or a day that starts with a T? So I want you to think about whether or not you think this event is mutually exclusive. And because of this key word, not sunny, these events are mutually exclusive because it will be sunny on Tuesday and Thursday, and those are the only 2 days of the week that start with a T. So the probability of not sunny and a day that starts with a T would be the not sunny days then would be Sunday, Wednesday, Friday, and Saturday. So that gives us 4 not sunny days, plus the 2 days that start with a T, Gives us a total of 6/7 probability. And our last example, we've got 26 students, 12 girls, 4 who wear glasses, 5 boys who wear glasses. And what's the probability that we choose a girl or someone who wears glasses? So think about whether or not you think this event is mutually exclusive or overlapping. And this event will be overlapping because there are girls who wear glasses. So you can choose a student who is both a girl and wears glasses. So the probability of girl or glasses would be, we have 12 out of 26 that are girls, plus 9 people who wear glasses out of 26, that's counting the girls and the boys, minus those girls that we double counted. We counted them as girls and people who wear glasses. So we have to subtract off the 4 girls who wear glasses. And that would give us 17 out of 26.